Welcome viewers. In this video we'll see the nodal analysis. The nodal analysis is the method to find the voltage at that given node. Node is nothing but a junction point. At a junction point we can find the voltage by using the Kirchhoff's current law. By using Kirchhoff's current law we can find the voltage at the given node. In previous method we have mesh analysis. Mesh analysis used to find the loop current. In a closed loop, what is the current flowing in the closed loop by using Kirchhoff's voltage law. That is available in the another video. The description box, the link is available. The viewer can see the video, mesh analysis. So this one, nodal analysis, finding the node voltage using Kirchhoff's current law. So in node voltage method, one of the principal node is selected as a reference node. The common point is selected as a reference node. All other principal node, the voltage is assigned. Other than the reference node, other node, the voltage will be assigned. This voltage is with reference to the reference node. All the node having the voltage, the reference is the reference node. At each principal node, KCL is applied and the equations are obtained. We can apply the Kirchhoff's current law at each node and we can frame the equation. By solving the equation, we can find the node voltage. Right? In that there are two methods available, equation method and matrix method. First we will see the equation method by framing the equation. Now consider this diagram. So we have one network is available, the two voltage sources available, VA and VB. Here the resistors available, R1, R2, R3, R4 and R5. Now we need to assign the node as well as reference node. So this is the reference node, this is common point. All the elements are connected here. So this is the reference node. Another two nodes available here, node 1 and node 2. So what is the mean by node? It is a junction point. See this node 1, R1, R2, R3 are connected together. Similarly at node 2, R2, R4, R5 are connected together. So node is the junction point. At that particular voltage will be assigned. Here node 1 voltage V1 is assigned. At node 2 voltage V2 is assigned. So this is nothing but VA, supply voltage. At this point VA will be available, at this point VB will be available. So we have two voltage sources, the resistors are available. We assigned one reference node at the bottom, normally it's a return path. Then we assigned the two nodes, node 1 and node 2 at this point. At node 1 the voltage is V1, at node 2 the voltage is V2. The node is nothing but junction point, in that the elements are connected together. So our aim is to find this voltage V1 and V2. What is the voltage at this point? So here we are going to apply the Kirchhoff's current law. What is Kirchhoff's current law? At a junction, incoming current is equal to outgoing current. Incoming current means current flowing towards the node. Outgoing current means current flowing away from the node. Both are equal. Otherwise, at a junction, total current is equal to 0. If any junction, if we add all the current, it will be 0. One current may be incoming current, one current may be outgoing current. So the total current is 0. That is given by the Kirchhoff's current law. Incoming current is equal to outgoing current at a node. Otherwise, at a node, the total current is equal to 0. So we are going to apply this Kirchhoff's current law at this node 1. What is that? We need to find what is the current in this node. There are three elements available, R1, R2 and R3. So we need to find what is the current through this R1, what is the current through this R2, what is the current through this R3. By adding all this current, that is equal to 0. That is the Kirchhoff's law given. Kirchhoff's law given that the total current in a node is 0. How will you find the current in this branch? Current I equal to V by R. R is available, R is R1. What is V here? This R1 is connected between these 2 points. At this point the voltage is V1, at this point the voltage is VA, the supply voltage. So voltage across this R1 is V1 VA, the difference between V1 and VA. So we consider the node 1, so it is V1 minus VA. Always we need to refer this node 1 because we are going to apply the Kirchhoff's current law at node 1. So V1 minus VA is the voltage across R1. Right? So we need to find the current through R1. Current I equal to V by R. V is nothing but V1 minus VA because R1 is connected between the node 1 and the supply voltage. So the difference between these two voltages is the voltage across R1. So V1 minus VA divided by R1. So this is the current flowing through resistor R1. Then what is the current flowing through the resistor R2? So R2 is connected between node 1 and node 2. The node 1 V1, node 2 is V2 voltage. Right? So the voltage across R2 is V1 minus V2 divided by R2. So this is the current flowing through the resistor R2. Then one more resistor available, R3. So R3 is connected between V1 and reference. Normally the reference voltage is 0. So only V1 is available. So V1 divided by R3 is the current flowing through the resistor R3. So that is equal to 0. So that is a statement given by Kirchhoff's current law. The sum of flowing current in the junction is 0. So in this junction there are 3 current. One is current flowing through R1, R2 and R3. So this is the current flowing through R1, R2, R3, that is equal to 0. Right? So current is nothing but voltage by resistance. Resistance value available. Voltage we are calculated from this. V1 minus VA in case of R1. V1 minus V2 in case of R2. V1 minus 0, that is V1 in case of R3. So that is very simple. So by using that we framed one equation, that is termed as equation number 1. Now we can apply the Kirchhoff's current law to the second node, node 2, this second node. Minimum we need 2 equations, then only we can find V1 and V2. We need to find 2 parameters. So we need 2 equations. Now we can apply the Kirchhoff's current law to this node 2, in that the voltage is V2. At node 2 what are the elements available? R2, R4, R5. These 3 elements are connected. Now we need to find what is the current flowing through R2, R4 and R5. What is the current flowing through R2? Current is nothing but voltage by resistance. What is the voltage? It is connected between node 1 and 2, V1 and V2. Connected between V1 and V2. Now we are applying node 2. So we need to refer V2 minus V1. In case of node 1 means V1 minus V2. There we are applying node 1. Now it is node 2 means we need to take node as here. First we need to take node 2, then node 1. So V2 minus V1 by R2. Right? So V2 minus V1 by R2 is the current flowing through R2. What about R4? R4 is connected between second node and reference node. So that only we have voltage V2. V2 by R4 is the current flowing through the resistor R4. We have one more resistor available, R5. What is the current here? V by I. What is the voltage? V2 and VB is connected between node 2 and supply voltage. So V2 minus VB divided by R5. Right? So this is the current flowing through R2, R4 and R5. Sum of this is equal to 0. That is a statement given by the Kirchhoff's current law. Now we got 2 equations. So by solving equation 1 and 2, we can able to find the V1 and V2. Right? So the nodal analysis means we are going to find the node voltage by applying Kirchhoff's current law. This is equation method. One more method is available, matrix method. Now we'll see this matrix method. Now we'll apply the same network for matrix method. The same network is available here. VA, VB and resistors are available. Node 1, node 2, this is reference node. Node 1 voltage is V1, node 2 voltage is V2. Same circuit. But here we are going to apply the matrix method. What is matrix method? We need to frame this matrix. I equal to V by R. I, this is the current matrix. Voltage matrix, this is resistance matrix. What is the formula based on Ohm's law? I equal to V by V divided by R. So that here written as 1 by R. Here 1 by R. We need to frame the resistance matrix, voltage matrix and current matrix. First we will find the resistance matrix. What is available here? 1 divided by R11, 1 divided by R12, 1 divided by R21, 1 divided by R22. What is 1 divided by R11? What is R11? R11 is nothing but resistors connected in the node 1. 1 refers what are the resistors connected in node 1. What are the resistors connected? R1, R2 and R3. These three resistors are connected at node 1. That is nothing but R11. So I can write 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. Right? So R11 is nothing but at node 1 what are the resistors connected we need to add. What is R12? R12 means the resistor connected between node 1 and node 2. Connected between node 1 and node 2. What is the resistor connected between node 1 and 2? R2. This R2 is connected between node 1 and node 2. So that minus 1 by R2. What is 2, 1? That also same. The resistor connected between second node and first node. Both are same. Connected between first node or second node to first node is nothing but R2. So minus 1 by R2. Right? So R12 and R2 are also calculated. Other than diagonal, these elements are negative. We need to follow the procedure. Other than diagonal, we need to put negative sign. What is R22? R22 is nothing but the number of resistors available in the second node. What are the resistors available? R2, R4, R5. These three resistors are available at the node, second node. So 1 divided by R2 plus 1 divided by R4 plus 1 divided by R5. Right? So R11 is nothing but resistors available at node 1. R1, R2, R3. R22 is nothing but resistor connected in second node. R2, R4, R5. R12 or R21 means connected between node 1 and 2. Commonly connected between node 1 and 2. So by using that we can frame the resistance matrix. Then what is the voltage? V1 and V2. The voltage matrix is V1 and V2. That only we need to find. What is current matrix? I1 and I2. How will you find this I1 and I2? I1 equal to VA by R1. Because current is not available here. We can find the current at this loop is VA by R1. Supply voltage. VA by R1 will give the current in this node. Similarly, I2 can be calculated VB by R5. This supply voltage and R5 will give the current in the second node. Now we framed the resistance matrix, voltage matrix and current matrix. Then how will you find this voltage V1 and V2? For that we need to consider this is the delta. This matrix is nothing but delta matrix. This is treated as delta. See this. This matrix is delta. By finding the determinant value, we can find the del. By finding this determinant, we can able to find the del value. Then we have del 1 and del 2. What is del 1 and del 2? If the first column is replaced by the current. What is current? I1 and I2. I1 and I2 is known as VA by R1, VB by R5. Right? So the first column is replaced by the current matrix, that is delta 1. If the second column is replaced by current matrix, that is delta 2. Right? So delta is nothing but resistance matrix. Delta 1 is nothing but in the resistance matrix first column is replaced by current matrix. Delta 2 is nothing but second column is replaced by current matrix. Now we can find the determinant value delta, delta 1 and delta 2. From that we can find this V1 and V2. Formula is available. V1 is delta 1 by delta. V2 is delta 2 by delta. So finding this by using this formula we can able to find V1 and V2. So in this video we saw what is the nodal analysis, how to find the node voltage by using two methods, equation method and matrix method. The solved example for this solved problem for this nodal analysis available in the next video. The link is available in the description box. The viewers can see the solved problem in the nodal analysis. Thank you.